high power settings, the multi-kilowatt thermal power, when you're actually performing those big maneuvers where you have to either insert or escape from planetary orbit. Now, let's talk about the radiation issues. The most powerful reactors ever operated were operated by the US as part of these NERVA rover test programs. They were generating thermal powers of something like 4 gigawatts, and at that power, that is equivalent to like 1 ton of TNT being exploded every second. So naively, I presume that every 10 seconds is equivalent to a 10-ton yield nuclear warhead, which is the smallest warhead the US ever deployed, the Davy Crockett, and that would kill people.
Proof positive. That the wind of the thermatic fan actually crosses the hut. And disturbs the hang of a Spitfire. Suspended in the smoke trail of a Dhoop-Cone. Particular species of incense. Designed to use the heat of the combustion on the outside of the tapered cone to vaporize scented resin in the core with a hole. So the relatively cool, relatively heavy, relatively dense smoke falls out the bottom. It's actually condensed vapor. And in a sufficiently still room, you can get it to cascade. Down the atmospheric ponds, so to speak. The Spitfire weathercocks. In the airflow. Coming off the thermatic fan.
In a 160-meter radius with radiation alone, instantly. So that is a pretty lethal amount of neutron radiation which would be coming off one of these engines.
Thank you, Scott. That was a lovely little quiet period for me to fill in.
On radiation shielding around this. So instead what you do is you put the crew or the payload at the far end of the propellant tank, and then at the top of the engine you put a very, very narrow shield that protects in just that one direction. It essentially creates a shadow in the radiation. It's called a shadow shield, and you can imagine casting a shadow where there will be none of this lethal radiation during the operation. Obviously having a full fuel tank there is going to help as well, but you can't rely on that once you've depleted your fuel tanks. reminder that when it puts out lots of radiation while it's operating, once it stops operating, there is still decay radiation coming from all those fission products. So when you're designing missions which involve nuclear thermal thrusters, you want to make sure that they don't have to fire their engine when they're, within, say, 100 miles of the space station. And when the spacecraft gets to its destination, the engine, that means that every time a payload comes up, it has to carefully navigate down this shadow shield channel, dock, and then actually perform its injection towards the target. Disposal is also an interesting problem because while it's out in space, it may eventually come back to Earth, and you would like to make sure that the radiation has decayed sufficiently. With Draco, I believe the plan is to put it up into quite a high orbit where there are no other spacecraft.
We definitely have forward airflow, or forward airspeed from the surrounding airflow while being held static.
Falling back to Earth, or boosting itself out into space and perhaps eventually falling back to Earth via some other route. So yeah, this is
not actually a bad achievement.
Almost certainly going to happen, and if used right, it can
even if I do say so myself.
Ability to explore the solar system. It's not, however, like what we have in Kerbal Space Program, where you can put them right next to your crew and you can turn them on and off instantly. No, this is a way more complicated specific impulse, so those will continue to dominate their niche. But also, I should be clear that I only talked about
welcome to the temperature inversion, where it's too warm for the smoke to ascend beyond.
Melt and use a melted core of liquid fissile material, or even a vaporized core, and no doubt next level in terms of their engineering challenges. There's also other possibilities for propellant. So we've talked about hydrogen, but another option is ammonia. It has the advantage that liquid ammonia is still
Warbles on the YouTube.
without the headaches of storing liquid
Ciao.
hydrogen.